Hello dear student, this is your question. Here we have to find the integration of dx over under root x plus a plus under root x plus b. So in order to find the integration, we can write I is equal to integration of dx over under root x plus a plus under root x plus b. Now here we multiply numerator by x plus a minus under root x plus b divide by under root x plus a minus under root x plus b. See here, this becomes integration of under root x plus a minus under root x plus b, and this is equal to a square a plus b into a minus b, that is a square minus b square. So here we can write it as x plus a minus x minus b. So x cancel out, so the integration become this one. So I is equal to 1 over a minus b integration of under root x plus a minus integration dx minus integration of under root x plus b dx. So this is equal to 1 over a minus b into integration of x plus a is equal to x plus a to the power 3 by 2, and x plus b integration of x plus b under root is equal to x plus b to the power 3 by 2 divide by 3 by 2. So overall plus some integration constant c. So overall we can say that I is equal to 2 over 3 into a minus b into x plus a to the power 3 by 2 minus x plus b to the power 3 by 2 plus integration constant c. So if we look at the option, we see that the option B is correct. Hello dear student, this is your question. Here we have to find the integration of e to x to the power 5 into e to the power x square dx. So first of all we write it as integration of x to the power 5 can be written as x square to the power 2 into e to the power x square, and we here multiply 2 into x dx, and since here we multiply by 2, so we multiply all over integration by half, so as to there is no change in integration. Now if we assume that x square is equal to t, then the above integration is equal to half integration of t square into e to the power t into 2x dx is dt. That's why we multiply here by 2 and divide by 2. Now this is the integration which is a function, which is a product of two functions, that is one is algebraic one and other is exponential one. So we use here integration by parts, which formula is written downside. So I can be written as I is equal to half into integration of half into fx is taken as t, and integration of e to the power t dt minus integration of differentiation of t square with respect to t into integration of e to the power t dt whole integration dt. Now this is equal to half into t square into e to the power integration of e to the power t into e to the power t minus integration of differentiation of t square is 2t into integration of e to the power t is e to the power t dt. So here we see that this integration I is equal to half into t square into e to the power t minus I2, 2 into I2, where I2 is integration of t into e to the power t minus t. So we have to find here I2. So I2 is equal to, I2 can be written as is equal to integration of e to the power t into t dt, right? E to the power t into t dt. Again here we apply the integration by parts, and I2 can be written as, see here, I2 can be written as t into integration of e to the power t minus integration of differentiation of t with respect to t integration of e to the power t dt whole integration, right? So this is equal to, I2 is equal to t into e to the power t minus differentiation of differentiation of t dt is 1. So this is integration of t e to the power t dt. Now this I2 is equal to t into e to the power t minus e to the power t dt. So I can be written as, from I is equal to half t square into e to the power t, half t square into e to the power t minus 2 I2. From here I is half into t square into e to the power t minus 2 I2. So this is equal to half into t square into e to the power t minus 2 into I2 is t into e to the power t minus plus e to the power t, right, plus integration constant c. Here dt is not there, so here we can write it as, if we put t is equal to x square, we can write half into x4 into e to the power x square minus minus half into 2 is 2, that is this is equal to x square into e to the power x square plus here the multiplication of I2 is with 2 is in both, so here also 2 and after that 2 half into 2 is cancelled out and e to the power x square plus integration constant c. So if we look at the option, we see here option A, which is equal to half x to the power 4 e to the power x square minus x square e to the power x square plus e to the power x square plus c is correct one. So option A is correct one. Hello dear student, here we have to find the integration of 1 over x square minus 1 under root 1 plus x square dx. So this integration can be written as, see here, if we substitute x is equal to 1 over t, then the above integration can be written as I is equal to integration 1 over t square minus 1, right, into 1 over t square plus 1 to the power 1 by 2 into dx is equal to minus 1 over t square dt. Now here we take LCM and the denominator become 1 minus t square, here denominator become 1 plus t square, with t square is in square root. So after rearranging we can write it, I is equal to t square into t divide by 1 minus t square into 1 plus t square to the power half into minus 1 over t square dt. See, t square cancel out and the above expression become, if we put y square is equal to t square plus 1, that is 1 plus t square is equal to y square, then here we see that t dt is equal to y dy. So the above integration can be written as I is equal to minus integration of t dt divided by 1 minus t square, that is 1 minus t square can be written as y square minus 1 minus t square, here t square can be written as y square minus 1, since y square minus plus 1 into, here see, into 1 plus t square is y square to the power half into t dt. Now here 1 plus 1 is 2 and 2 minus y square, the expression become minus integration of t dt, that is y dy, see here y dy over y square minus 2, y square minus 2 into y. So y and y cancel out, so the above integration can be written as I is equal to integration of 1 over y square minus y square minus root 2 to the power square dy. Now as we know, integration of 1 over x square minus a square is equal to 1 over 2a log mod of x minus a over x plus a. So putting this integration in this standard one, that is we get I is equal to integration of I is equal to 1 over 2 root 2 into log modulus of y minus root 2 divided by y plus root 2, right, plus integration constant c. Now as we assume that y is equal to, here we assume that y is equal to t square plus 1, so we can put here 1 over root 2 log this is equal to t square under root y is equal to t square plus 1, so y is equal to t square plus 1 minus root 2 divide by under root t square plus 1 minus root 2. Now again we substitute the value t is equal to 1 by x, then I become 1 over 2 root 2 log mod of under root 1 over x square plus 1 minus root 2 divide by under root 1 plus x square plus 1 minus root 2 plus some constant c. So if we rearrange it, we get the final answer, and after rearranging we get I is equal to 1 over 2 root 2 log modulus of under root 1 plus x square, see here LCM is x square, so 1 plus x square minus 2 root 2x divide by under root 1 plus x square minus root 2x, and the denominator part of this one x, that is x and x cancel out, so our answer is I is equal to 1 over 2 root x log mod of under root x square minus root 2x over under root 1 plus x square minus root 2x plus some constant c. So if we look at the option, we see here the option 1 over root 2 root 2 log under root 1 plus x square minus root 2x minus root 2x plus and in denominator plus 2x. So option C is correct one. Hello dear student, this is your question. Here let us assume I is equal to the given integral, that is integration of 1 over x square under root 1 plus x square dx. Now if we here put x is equal to tan theta, then dx is equal to sec square theta d theta, and I become this is equal to integration of dx is equal to sec square theta d theta, right, and x square is equal to tan square theta under root 1 plus x square is equal to 1 plus tan square theta. As we know, sec square theta minus tan square theta is equal to 1, so 1 plus tan square theta is equal to sec square theta, and this can be written as integration of sec square theta d theta divided by tan square theta into under root 1 plus tan square theta is sec square theta, and after taking it from square root it become sec theta. Now sec theta cancel out, so I can be written as integration of 1 over sec theta is cos theta, right, into tan square theta can be written as sin square theta divided by cos square theta into d theta. See, cos square theta in square is cancelled out with cos theta, so the given integral become integration of cos theta divided by sin square theta d theta. Now if we put sin theta is equal to z, so differentiation of sin theta, that is dz, is equal to cos theta d theta. So this is equal to cos theta d theta is equal to dz, so this integration can be written as dz over z square. Now this integration after integrating becomes z to the power minus 2 plus 1 divided by minus 2 plus 1, so this is equal to, so I becomes minus 1 over z, that is plus integration constant c, so minus 1 over z is sin theta plus integration constant c. Since we assume that tan theta is equal to x, so this is equal to p perpendicular over base. So if we find out hypotenuse, it is equal to under root p square plus b square, that is x square plus 1. So sine theta is nothing but perpendicular over base, that is p over h. So sine theta can be written as, here p is equal to x over under root x square plus 1. So if we put this value, I become minus under root x square plus 1 divided by x plus integration constant c. So if we look at the option, we see here the option A, that is minus under root 1 plus x square plus divided by x plus c, is correct one. Hello dear student, this is your question, right? So first of all, we write I is equal to integration of x to the power 3 under root 3 plus 5x4 dx. Now if we put here 3 plus 5x4 is equal to t, then dt is 20x cube dx. So here we see that we have x cube, so if we multiply it by 20 and same divide by 20, there is no change in integration, but we got 20x cube dx, which is equal to dt. So this integration can be written as 1 over 20 integration of under root t dt. Now integrating this, we get 1 over 20 into t to the power half plus 1 divided by half plus 1. This is plus integration constant c. This is equal to 1 over 20 multiplied by 2 over 3 into t to the power 3 by 2 plus integration constant c. So here we see that this integration, if we put the value of t, is equal to 1 over 30 into t is 3 plus 5x4 raised to the power 3 by 2 plus integration constant c. So if we look at the option, we see here option C, which is equal to 1 over 33 plus 5x4 to the raised to the power 3 by 2 plus c, is correct one.